Okay, so this video is on finding relative max and min as well, but this is about the difference between using a first derivative test and a second derivative test. So I'm going to go over kind of the basics of each. So for the first derivative test, your first step, and this is going to be the same for the second derivative test as well, is going to be find f prime of x to find critical values. So remember, this happens when f prime is either equal to 0 or is undefined. Once you find that, then step 2 for the first derivative test is to create a number line. And use it to determine the sign of f prime before and after the critical values. If the sign of f prime goes from positive to negative, then you have a relative max. If the sign of f prime goes from negative to positive, then you have a relative min. So let me just put this here. Relative max, relative min. So that would be the first derivative test. The second derivative test, you start out the same way, so it's the same as step 1 over here. You're going to find f prime of x to find critical values. Step 2 then is going to be find f double prime of x. F double prime checks the graph's concavity, so it will tell you whether the graph is concave up or concave down. So then what you do is you test your critical values in f double prime. If f double prime is positive, if the critical value gives you a positive f double prime, that means your graph is concave up, which would mean you have a relative min. If your f double prime is negative, then your graph is concave down, which would imply that you have a relative max at that value. Okay, so we're going to just do a practice example, and I'm going to use the second derivative test if possible because you guys already saw a video of using the first derivative test. And I'm going to, if it doesn't work, then I will go back to the first derivative test. There is possibility that the second derivative test does not work. So first thing I'm going to do is find f prime of x. In this case, we have to use the product rule, so I'm going to go ahead and write my two functions over here. The derivative of x is 1. The derivative of e to the x is e to the x. So our equation is now x e to the x plus e to the x times 1. And so I'm going to set this equal to 0. But first I'm going to factor out e to the x. So I have 0 equals e to the x times x plus 1. And if you guys remember the graph of e to the x, it looks like this. E to the x will never equal 0. So I only have to focus on when x plus 1 equals 0, which is at x equals negative 1. So the next thing I'm going to do is I'm going to find f double prime of x. So f double prime of x is probably easier to find using the factored form. So again, this is a product rule, so I'm going to set up my two pieces here. I have x plus 1, and then I have e to the x. The derivative of x plus 1 is 1. The derivative of e to the x is e to the x. And so I get x plus 1 times e to the x plus e to the x. And again, I can factor out e to the x. So I have f double prime of x equals e to the x times x plus 1, which is x plus 2. And now at this point, what you do is you're going to test negative 1 into f double prime. So you're going to find f double prime of negative 1, and you get e to the negative 1, which is positive, times negative 1 plus 1 plus 1. And that's also positive. So if I have two positive numbers, overall this is positive. So the sign of f double prime is positive, which means that the graph is concave up, so we have a relative min. So there's a relative min at x equals negative 1 because f double prime of negative 1 is greater than 0 or is positive. So I'm going to do a second example. This one's just a straight polynomial. So again, the first step is going to be find f prime of x. And we get negative 3x squared plus 6x minus 3. And I'm going to go ahead and factor out a negative 3 here and set it equal to 0. So negative 3, and then I have x squared minus 2x plus 1. And so this ends up factoring as negative 3 times x minus 1 squared. So I can't set negative 3 equal to 0, so I get x equals 1. That's the only factor here because it's a repeated factor. Now I'm going to use the second derivative. So my second derivative is negative 6x plus 6, and I'm going to plug in 1. You end up with negative 6 plus 6, which is 0. So we cannot use the second derivative test because we did not get a positive number or a negative number. So the second derivative test doesn't apply. So we have to go back to the first derivative test. So what I would do for the first derivative test, again, is I would make a number line. I would put 1 on it. And I'm going to test a number before and after your critical value. So if we plug 0 into our first derivative here, we have a positive number and then a negative number. So overall, this is negative. If we plug 2 in, we have a negative number again, and we have a positive number again, so this is negative. So our derivative goes from negative to negative. It does not change signs. So x equals 1 is neither a relative max nor relative min.